Okay, in this video I'm going to be talking about derivation of a class of implicit wrong cutter methods called Radau methods. I never know whether I'm pronouncing that correctly, so yeah, just have to okay, I'm going to start that again. In this video I'm going to be talking about the derivation of a particular type of implicit wrong cutter method called Radau methods. Now, Radau methods, for an S-stage method, so for an S-stage method, Radau methods have order 2s minus 1. Okay, so a bit different from the Gauss-Legendre method. Gauss-Legendre method, an S-stage method, had order 2s. Well, what Radau methods do is they sacrifice a bit of order, a bit of accuracy, but for much better stability properties, and we'll be dealing with stability later on in the unit. Okay, there are actually a couple of different types of Radau methods. So the Radau 1A method, actually there's quite a few different types. So we're going to be looking at Radau 1A. What we do is we let C1 equals 0 and Ci, so for example when I equals 2 up to how many stages we have, these are the roots of this polynomial. Okay, so PS is a Legendre polynomial. I just rewrite that. Yeah, PS is the Legendre polynomial. See the video on Gauss-Legendre methods for a little bit of an explanation on that. Okay, so let's say we have a two-stage Radau method. So our C1 and C2, or C1 will be 0, C2 will be the root of P2 P2t plus P1t. The B coefficients will satisfy, or chosen to satisfy, the BK condition or B2S condition, and the Aij coefficients are chosen to satisfy the CS order condition. Now for these, so what I'm talking about with the B and the C order conditions, see the lecture notes or the video on the Gauss-Legendre methods. So that's the first type of Radau method. Okay, the next type we're going to be looking at is the Radau 2A method. So Radau 2A. Now this is where the C2 is going to be set equal to 1, or not C2. It's when CS is equal to 1 and all the other C values, for example where I is 1 up to S minus 1, okay, are chosen as the roots of the polynomial, the Legendre polynomial PST minus PS minus 1t. Okay, so that's the difference. So the Radau 1A method, we chose C1 to be equal to 1, and the other values of C were chosen to satisfy PST plus PS minus 1t. Well, with the 2A method, we choose the last coefficient for C, CS, to be 1, and all the others satisfy PST minus PS minus 1t. Okay, so those are the two methods we're going to be looking at, and the B conditions are chosen to satisfy B2S, and the Aij are chosen to satisfy CS. So that's the same as the Radau 1A. So the difference between the two is how we calculate the C coefficients. So we're going to look at example 3.3 in the notes. Alright, so example 3.3, I'm going to say derive. We want to derive a third order Radau 1A method. So the first thing we need to ask ourselves is how many stages. So remember, for Radau methods, the order K is 2s minus 1. So if k is 3, we'll have 2 stages. So again, I always find it useful just to remind myself what a butcher tableau will eventually look like. Now with a Radau 1a method, we always choose in C1 to be equal to 0. Okay, so we need to solve for C2. We solve for A11, A12, A21, A22. Okay, so we already know what one of our C values is. Okay, so we need to solve for the other C value, and this is a root of P2T, because that's PS, so remember S is 2, plus P1T. Okay, so that's going to be 220, 220 times T minus 1 to the power 0, plus 2 choose 1, 3 choose 1, T minus 1 to the power 1, plus 2 choose 2, 4 choose 2, T minus 1 to the power 2. So that's your P2T. My T's looking a bit like a plus. P1T, so that's going to be 1 choose 0, 1 choose 0, T minus 1 to the power 0, plus 1 choose 1, 2 choose 1, T minus 1 to the power 1. Okay, so if you simplify that, a little bit of algebra, we get 6t squared minus 4t, or in other words, t 6t minus 4. Okay, so you can see the roots of this quite easy, so that implies that our C2 value is going to be 2/3. Okay, so when t is 2/3, we have this equal to 0. Okay, so we know C1, and we now know what C2 is, and we've got 4 coefficients to solve for, and this is quite similar to the if you had a look at the Gauss-Legendre method. Okay, so the B value's got to satisfy B2s, so we've got to satisfy B4, but remember we only need B1 and B2, so we only need the first 2 equations. So B1, well, B1 is going to be multiplied by C1. But remember C1 is 0, so I can actually just take that out and ignore that, and we'll have B2 times C2. Well, we already know C2 is 2/3. Don't need that plus, do I? Just gonna get rid. Okay, and our A condition, so the Aij, they need to satisfy C2. Okay, so what we have there is we'll have our row sum conditions. So A11 plus A12 is chosen. It's going to be equal to C1. Well, that's going to be 0, but I'll leave it in there for now. Actually, just for completeness, I'll put that back in. And our second row sum condition, and we've got the case when L is equal to 2. So we've got A11 times C1, which is going to be 0, but I'll leave it in there for completeness. And A12 times C2 is equal to 1/2 C1 squared, and A21 C1 plus A22 times C2 is equal to 1/2 times C2 squared. So again, we have 6 order conditions, so we've got all of these. So we've got 6 equations, and we've got 6 unknowns. Remember, we know what C1 and C2 are. So if we solve, again, don't bother trying to do it by hand. So solve using some software. In the webinars, I'll show you how we can use MATLAB to solve these order conditions. Okay, so if we do so for if we solve these, the result is we already know that C1 is equal to 0, C2 was 2/3, we already knew that. If we solve for the rest, B1 is equal to 1/4, B2 is equal to 3/4. A11 and A12 both equal 0, A21 and A22 both equal 1/3. Okay, so if we put that in our butcher tableau, we got our B values, we got our C values, and we have our A values. So this is the third order Radau type 1A method.